Welcome back. In this video, we're going to try to find this limit. So our function here is x minus the square root of x squared minus x. Most of the time when we are dealing with this kind of limits, the first thing that we do is we start and evaluate and we see what's going to happen. Here we know that x, this is as a function, goes to plus infinity as x goes to plus infinity, and the square root of x squared minus x will go to plus infinity if x goes to plus infinity. But with this minus here, we're gonna have plus infinity minus plus infinity, which is gonna give us plus infinity minus infinity. And we don't know how to deal with this kind of problems, okay, because how the infinity is defined minus this infinity. So most of the time here we have to rework this one to find the limit. But before doing so, we need to find the domain of definition here to see if we reach infinity. So here the condition that we need to have is that to be able to define the square root is we need to have x squared minus x bigger or equal than 0. This means, because we are interested in infinity, so here that means that x is bigger than x minus 1. X times x minus 1 is bigger than 0. And that means here, since we are interested in the positive values, okay, we can do a quick table here. It's minus positive here, minus minus positive values here, and therefore we see that we have this one is defined between minus infinity 0 union 1 plus infinity. Okay, so this is the domain of definition of our function here, right, of this square root here, and this is defined on R. Therefore we intersect this one with this one, and therefore the function is defined on this interval. Okay, so here we see that we can reach infinity, and infinity is part of the interval. So the quickest way to find in this limit is we can do when we see the square roots, we can do the conjugate. Okay, we multiply by the conjugate, and to do that we're just gonna do the limit of x minus the square root of x squared minus x times x plus the square root of x squared minus x over x plus the square root of x squared minus x. Okay, assuming that this one is never 0. Okay, here now we can do the we multiply, remembering that we can treat this one as a and the square root as b. So we have a minus b times a minus b, which is a squared minus b squared. Here we have x squared minus the square root of x squared minus x squared, okay, over x plus x squared minus x. And remember one thing here is that this value here is always positive. Okay, you can prove it here. So this value here inside is always positive. So here, therefore, we have x squared minus x squared plus x over x plus the square root of x squared minus x. And this gives me the limit as x goes to plus infinity of x over x plus the square root of x squared minus x. Okay, now nice. So here I get to something simple. Not simple. No, because not here. This is plus infinity, and this is plus infinity plus infinity. So I still have a problem. Now we have this one instead of this one. Okay, but x is never 0. I can divide by x. So doing that, so I'm gonna get here 1 plus, and since x is positive here, I can enter that inside the square root, because x is going to plus infinity. That means x is positive. So we can do this. Again, I can get x squared over x squared minus x over x squared. Okay, remember, I factor out by this one here, and to be able to enter that, I have to write it as x is the square root of x squared. Okay, and I do it here. Or I can get x squared, because I see this problem a lot. So I can do the following here. Here, let me do this one here. So here, x, these pencils from China are a problem. X squared minus x. So here, x plus, I can factor out by x squared here. I have 1 minus 1 over x. Okay, now I use the fact that this is positive. I can multiply the roots. So I have the square root of x squared times the square root of 1 minus 1 over x. And here, what's this one? If x is positive, it's just x plus x times this one. Now I can factor out by x. So x plus 1 minus 1 over x. And with x on top here now, I can simplify. So I can simplify. You see that? Now I go back to my computation here, and I see that x is never 0. So I'm going to get the limit of 1 over 1 plus. This is just 1. This is just 1 over x. And now I can see that I can get some limits. I can evaluate again. I have 1, 1. What's this limit here as x goes to plus infinity? We can enter the limit inside. The square root is a continuous function. So here I have the limit of 1 minus 1 over x as x goes to plus infinity, which is 1. Okay? So therefore I have 1 over 1 plus 1. This is 1 over 2. So this is the limit. So sometimes we need to justify these computations here. Okay? Because sometimes you get x squared. You are not going to plus infinity. You're going to minus infinity. You have to deal with that. So here, that's the key here. And you need to pay attention to this. Okay? I think that's it. Our limit now, we know our limit is 1/2. Okay? And the question is this limit on top of the graph or below the graph? That means, assuming that our function looks like this. So this is 1/2. So let's say this is 1/2. So this is 1/2. So is the limit here? Is it on here? Is the graph? This is the limit. Is the graph here or here? Okay. Good question to answer. Thank you very much.